Okay, Year 12, our next topic is annuities. Now, this is a topic that we share with Standard. The trouble is, when we share it with Standard, they tend to use tables or the given set formulas, whereas we see it as a geometric progression. So annuity, there's a little explanation here of annuity, comes from the Latin word, and it means yearly. Now, the way an annuity works, well, here's an example here. So Stevie's grandparents, they put $100 into the bank account on her first birthday, and every year they put another $100. Now, that at the end of the first year, there's $100 in the account, but there's interest being earned on the account. And you can see here, there's an interest rate. So at the end of the second year, that $100 has earned 2%. Yeah? So they get $102. But they put another $100 in. So there's $202. At the end of the third year, that $202 is now earned interest. And they've put another $100 in. So you keep building it like that. And we're going to show later on how to do that with a geometric progression. And it gets pretty complicated, which is why a lot of people use tables or spreadsheets. So here's the table. I'm not going to be able to read that because it's sideways. So I've got my hard copy book here that I'm going to be reading off. And there's an important note here that unless an annuity is stated otherwise, all payments are at the end. You can put money at the beginning of a period, but most of our questions will have the money going in at the end. So there's another example. All right. But this time they use the table, and we're gonna do that ourselves. The other sort, you can use a table in reverse to find out how much you have to put in to find to have a certain amount. So let's say here, this example, $20,000 to buy a car. You know the interest rate. How much will you have to put in each month? So you go to the table and you find this number, all right? And the future value equals whatever you're going to put in times that number. So you just write an equation, you divide by that, and that's how much money that they have to put in. We'll do an example of that. The other one is where you take money out. Okay, so let's imagine, and superannuation is just like a pension fund. Let's say you get a huge amount of money. I don't know. Let's say you got $145,000 and you go, wow, I'll put that money in, it's earning 12%. But then every month I'm going to take out $1,800 so that I can live on it. So what happens is, because you have to change everything to monthly, you get 1%, and you go, all right, at the end of the first month, it's earned 1%. But you're going to take out $1,800, so that's what's left. At the end of the second month, again, it's earned 1%, so that's what's in there. But you're going to take $1,800 out. And you keep doing that, and that's called a reducing. It's decreasing. Now, if she took less money out, and if you think about it, go back up here, if instead she only took 1,450, she would keep her balance in. So if she took 1,450 instead, she could keep a balance at 145, and then it wouldn't decrease. Or if she even took out $1,000 a month, it'd start increasing. All right? And that's what they want you to do there. All right, so let's have a go. Some of these questions. So I'm not going to do all of these because they take a lot of time. So let's just do a nice easy one. These are all yearly ones. So let's take 1B. And what are we doing? Calculate the future value of an annuity. That means what it's going to be worth at the end of each year. So what have we got? We've got $1,200. We've got 4%. And we've got 3 years. Okay. So at the end of the first year, and we're putting it in at the end. So at the end of the first year, 1,200. We put it in. There you go. There's 1,200. Saving for a car, for a holiday or something. It earns no interest because it has no time. At the end of the second year, my $1,200 has earned 4%, 1.04. Yeah. I know that they write 1,200 plus 4, but it's easier to do that. So I've gone up 1,200 times 1.004. 1248. 1248. But we've got to add another 1,200. So at the end of the second year, there is 2,448. And I'm just, okay. Now at the end of the third year, that 248 has earned 4%. So it's 2,448 times 1.04. I'm just going to double check 1,248 because I would have hated to have made that wrong, plus 1,200. Okay, and I times that by 1.04, and I get 254592. 2545.92. But remember, another 1,200 has been added. So I take that answer and I add 1,200. And I get the right answer. $3,745.92. Now, as you can see, if you were doing this for a lot, it'd take a long time. All right? So that's why they got the tables. Because if you want to do it for a long time, check out this one. 14 years. I don't want to do that for 14 years. So let's do it using the table. And of course, you're going to end up working out how to verify that the table is right, and we'll do that later. So here's 2H, and we're doing this from the table. What do we got? 598, 14 years, 9% per annum. So my future value is going to equal 598 times the magic number I'm going to find in the table. Now, because it's sideways, I'm going to go and find it here. So it's 14 years, so I'm looking at 14 and 9%, and, oh geez, very easy to make a mistake. You know I did that last time. I get 26.0192. 26.019, I'm just double checking. 26.0192. 192. And if you were to go back and use your table, here's my 14. And here's my 9. And you can see, there it is. We'll get rid of the pink stuff now. 26.0192. So once I've got that number, I just multiply 598 times 26.0192. Holy dooly. We're going to go to the nearest cent, so it's going to be 0.48. So 1,559.58. 1,559.48. Just checking. Beautiful. And that's the right amount. So if you put $595.08 away for 14 years and you're earning 9%. Now, if you would just put that 598, let's just see what the difference is. So 598, so 598 times 14, 8,000, we've almost earned double the value of the annuity in interest over those 14 years. Because if we just save 598 and for each year for 14 years without any interest, we'd have 8,372, whereas we've got $15,559.48. Righto. Why can they make it hard? Well, I'm going to do 3E. It's not that hard, but no. So I've got, I'll do D and E. So 3D. What am I doing here? I'm getting something paid every 4 months. So I've got 550. 550 is my principal, my present value. 3 times a year for 5 years. So 5 years at 3 times a year. Well, that's going to be important. And 6%. 6%. Now, if it's done every 4 months, that's 3 times a year. That means I'm going to get 5 times 3. I'm going to get 15 times of payments. But my interest rate is per annum, and I have to divide by 3 to get the 4 monthly interest rate, and 6 divided by 3 is 2. So my percentage is 2, my repayments are 15, and I got 550. So my future value equals 550. Now, how am I going to find this number? I'm going to look up 15% in the 15 times in the table, 2%, and I get 17.2934. So 17.2934. So 550 times 17.2934. 9511.37, which is the right answer. 9511.37. And there you go. 3E, well, it's monthly, 18 months, 587. So we've got 587, it's 12%, it's a month, so 18 months is my time period. 12%, 12 divided by 12, because it's done monthly, is 1%. So to find my future value, I'm going to take that 587, I'm going to multiply by the magic number, which I'm going to look up in the table. I'm going to go and find 1%, 18 periods. And that's 19.6147. So 19.6147. And again, it's just calculator work. 587 times 19.6147. 11513.83, and that's it. 11513.83. So they're pretty easy. If you go through all of these, you'll see now all these ones here, you're finding the amount that you have to put away. So I'm going to do 7E. 6E and 7. Righto. Find the amount of each contribution needed to give that. So if I want $1 million after 20 years at 8%, so here's 5E. I want to have $1 million, don't we all? So the future value equals $1 million. It's 20 years. Term is 20 years. 5%. So that equals some number, call it X, times 20 and 5. Well, 20 and 5, so I go into my table, 20 terms, 5%, 33.066. 33.0660. Well, to find X, I just divide it. So it's 1 million divided by 33.0660. That's my X. 1 million divided by 33.0660. What question are we doing? 5E and 6E, sorry. I must have written it down wrong because I'm slightly out. I've got the right amount. What size is it? 20 and 5%. What did I write? 33.0660. That's right. Did I have 33? They've got 30,242. Well, that's right. But they've got 55, whereas I've got 30,242. 30,242 equals X. They got 55 cents. I just wonder if I've done the right thing. Have I got the right amount? Is it 1 million? It is 1 million. 20 years, 5%. I've double checked that. 20 years, 5%, 33.0. I'm checking again. 20 years, 5%, 33.0660. Did I do that right in my calculator? 1 million, 1, 2, 3, 4, 5, 6 divided by 33.066. Oh, I've got too many sixes in there. There. There it is. There it is. So all I have to do is put the 55 in here. There we go. Righto. So with question 7, you're going to do the same thing, but it's 2 years, but they're doing it monthly. So there'll be 24 repeats of 1%. 24 repeats of 1%. And I said that was question 5, that was question 6. All right, so question 7, what does she want to have? 8,000, 2 years, 12%. 8,000, 2 years, what was it? 12%. So 8,000 equals X times, now the payments are going to be 48 because 2 times, not 48, 24. 2 times 12. 2 times 12 equals 24. And 12 divided by 12 is 1%. So I go and find the right number. 24, 1%, I get 26.9735. 26.9735. So 8,000 divided by 26.9735 equals X. Calculator, 8,000 divided by 29, 26.9735. 200, what was that? $296.59. So $296.59. That's how much she has to put away to have 8,000 by the end of the year. That's right. So that's how you use it. The only other things they're going to ask you: graph questions, no worries. Dave puts away superannuation payout into an annuity, takes out a pension of $500 a month. So that's the only other one they're going to ask you. So I'm going to come back tonight. I'm just going to look at these two. Use a future value table. All right, so they're asking you to find out how many payments. I can only say that you can guess and check for that. Use a future 6%. So I actually know you do. So here I'll do question 11 because we've been using the table. So we've got 50,000 is our future value, and we're putting an annuity of 2,000, and it's 6% per annum. So we're looking at 6%. So if I go, this is going to be 50,000 equals 2,000 times some number. We'll call it Y this time. So I go, 50,000. I forgot I've left off a zero there. 50,000 divided by 2,000, 25. So the magic number is 25. So I then go to the table, and it's 6%. So I go to the table, and I'm looking for 25. So 6%, and we're looking for 25. So we go down here, and we're looking for a number that's 25. And we can see that it's going to be somewhere there. So let's get rid of those two. So if she puts it in, or whoever puts it in for $16, she'll get 25.6, and if puts it in for $15, 23. So they're going to need to put it in for, and they've said 18. Am I looking at this the wrong way? 6%. They've gone 18. Now, why have they said 18? Have I got the question right? Oh, goodness me. $50,000 divided by 2,000. It's 25. At 6%. How many times from superannuation to be greater than 50,000? Well, it should be only 11A. Why are they going 18? Why am I making that mistake? Have I got the right value? I'm just going to use the textbook now. 6. I'm looking for 25. Surely it's only 16. Surely it's only 16 at the end of each year. At the end of each year. I'm pretty sure it's only 18. Let's try the other one and see if I stuff that up as well. It's already got, got the wrong colour for a start. Get back here. 80,000 equals 2,000 times this magic number. So 80,000 divided by 2,000, it's going to be 40. by 2,000. So I'm going down the 6% column and I'm looking for 40. I'm getting 22. They got 21, which will just not get there. It'll just not get there at 21 because it's 39.9. So 80,000 divided by 20,000, 2,000 is 40. And the closest number is 39. I don't know why I'm getting different answers. Let's have a look at their example and make sure I'm doing it correctly. 4 times a year interest rate. Yeah, right. I'm sure I'm right. I'm sure I'm right with those ones. So here I got 22 because if I look down the 6%, it'll be 39.9927. So I get 22 years. They only get 21. And the other one at 25, I get 17 years. Whereas they get 18. How many payments would Richard need? Oh, it's how many payments. How many payments? Okay, so it goes for 17 years, hence 18 payments. So I was right, 17 years, which means 18 payments. Because you got one in there? No, that should be right. How many payments? The other one is 22, and they've got 21. I'm going to have another look at those. All right, the only other one I want to do is question 9, because this, you have to do it bit by bit. So Dave puts 125,000 of his super in this annuity, and he's going to take out a pension. And he's going to take out it in a month, and it's 12% per month. So let's set this up. And it's going to be a long, drawn out one. Rightio. So what do we got? 125,000. 12%. But we're dividing by 12, so it equals 1% because we're doing it monthly. So after 1 month, it equals 125,000 times 1.01 minus, how much is he going to take out? Or 500. So that's what it is after 1 month. So 125,000 times 1.01 minus 500. 125,750. 125,750. Let's double check, make sure we're right. And we're right. Now, after 2 months, it's 125,750 times 1.01 minus 500. I've already got that in my calculator, so I'm going to go times 1.01 minus 500. 126507, 126507.5. Now, after 3 months, it's 126507.5 times 1.01 minus 500. Now the beauty of my calculator is I've done this twice, so if I just press equals, it should give me the answer saying, oh, do you want to repeat the process? And that's the right answer. The answer is 127,272.58. And what did we get? 0.575. Now, once you start rounding, you're going to start affecting this equation. All right? Because if you round that to 0.58, it's a little bit more. And financial institutions won't do that. They'll keep the number in there. They'll use a different form. So if you're doing it with 6%, it'll be a different value. You'd have to, if you use 6%, so that's A, B, and C. If you're using 6%, well, 6% divided by 12 equals 0.5. But it's a percent, so it'll be 0.005. So when you're doing it, A1 will be 125,000 times 1.005 minus 500. Now I wonder whether or not that is going to be enough to keep the principal . Yeah, it is. Right? So we'll do that again. 1.005 minus 500. Yep, and do it a third time. Double check the answer. What are we doing? This is D. Yep. That must be E. 376.88. I think she's got, in her answer, she's got it around the wrong way. Yep, so that's right. And then 3 months if Dave decides to take a pension of $1,000. Well, I don't know what interest rate, but you can have a go at that. All right, good luck with those.